Light plays an extremely vital role, serving as an irreplaceable element in human life. It sneaks through the door crack every morning, then dances on the water's surface as the sunset slowly fades. And even guiding night flights as they glide through the starry sky. Light has become a close companion, intimately connected to us in our daily lives. Something so familiar that few bother to ponder what its true nature really is. But if I tell you that light, at its smallest level, can tell a completely different story. A tale of 37 layers of space, where everything we thought we knew about the universe is turned upside down. What if it's just a small piece in a much bigger picture? At the beginning of 2025, a group of scientists announced a groundbreaking quantum experiment that shocked the research community. They realized that light, or more specifically, photons, the tiny particles of light, can simultaneously exist in 37 different dimensions. No, this is not a science fiction story. We step through the gateway into mystical realms, where countless wonders lie hidden. Instead, this is an exploration of how light operates in the quantum world, a world where everyday rules seem to bend, even turn completely upside down. This experiment is not just another dry scientific paper. It was like a whisper from the universe, reminding us that perhaps we still don't truly understand everything about this world. What is the result of this experiment? Why are the 37 dynasties so significant? And more importantly, could our understanding of the universe be flawed? Before exploring the mysterious realms of space, pause for a moment to appreciate the familiar light around you. Since childhood, we have been taught that light consists of rays traveling from the sun to the earth, carrying energy and colors. Renowned scientists like Newton used prisms to split light into a rainbow spectrum. Later, Einstein proved that light can also be bent when passing by massive objects like black holes. But by the 21st century, light had revealed a new property. It is not merely a wave or a particle, but simultaneously possesses both natures. A phenomenon known as wave-particle duality. Photons, the smallest particles of light, are the central characters of this story. They are so small that the naked eye cannot see them, yet they possess the power to shape how we understand the universe. Quantum superposition. Moreover, they can become quantum entangled with each other. A strange connection where the state of one photon instantly affects the other, no matter how far apart they are. If you measure a property of this photon, such as its spin direction, the state of the other photon will change instantly, as if they are communicating through an invisible channel. This entanglement is precisely what led scientists to the experiment we are about to explore. But first, brace yourselves because we won't just be discussing the familiar three dimensions of length, width, and height. That is a strange mathematical space where 37 dimensions are simply a way to describe the behavior of photons. This is not a physical space you can step into, but coordinates in an imaginary world, where the laws of quantum mechanics reign. On a freezing winter day in Denmark, a research team led by physicist Junghao Liu from the Technical University of Denmark activated a complex device. They were not searching for the answer to the question that had puzzled physicists for decades. Does reality truly operate the way we think it does? Their experiment was based on an idea called the Greenberger-Hanselinger paradox, named after the three physicists who proposed it in 1989. This paradox is a thought experiment demonstrating that quantum entanglement contradicts the classical viewpoint, which holds that all objects in the universe exist in definite states and are only influenced by their immediate surroundings. According to classical theory, we can predict the outcomes of these measurements based on the assumption that each photon already has a predetermined state from the outset. However, when conducting the experiment, the results obtained were contrary to classical predictions and fully consistent with quantum mechanics. This shows that reality is not an unchanging thing, but rather shifts depending on how we perceive it. Liu's research team conducted an experiment using photons to test the extended version of the Greenberg-Hanselinger paradox. They created a special state in which photons became quantum entangled in an extremely complex manner, to the point that a full description of this phenomenon required 37 dimensions in the mathematical space known as Hilbert space. Hilbert space may sound complicated, but in reality, it's just a tool that helps scientists describe the quantum world. Imagine it as a giant spreadsheet, where each column and row represents a possible state of a photon, such as position, spin, or entanglement state. In the simplest case, a photon can be represented in a two-dimensional Hilbert space. For example, it can rotate upward or downward. But when you add more photons and make them more entangled and complex, the dimensionality of the Hilbert space also increases. Dimension. In this case, the scientists created an extremely complex quantum entangled state using photons, so intricate that it required up to 37 dimensions in Hilbert space to describe it. They do not exist in a fixed state or location, but rather seem to stretch across 37 dynasties, challenging the notion that reality is simple and easily grasped. The most fascinating aspect of this experiment is its potential to transform the technology we use daily, or at least the technology the next generation will use in the coming decades. To help visualize, you can think of the computer you're using right now. This system operates based on bits, zeros and ones processed through ultra-small electronic circuits. But quantum computers operate differently. They use qubits, units of information that can exist in a state of 0, 1, or both simultaneously due to the phenomenon of quantum superposition. The experiment has taken this idea to a new level, with quantum entangled photons in a state so complex that it requires 37 dimensions to describe. They have the capability to store and process an enormous amount of information, far surpassing conventional qubits. Quantum computers with multi-dimensional processing capabilities can solve problems that would take conventional computers millions of years to complete. We often assume that the world around us is a stable and certain place in everyday life. If you place a cup of coffee on the table, it will stay there until you pick it up. However, quantum experiments have proven that at the microscopic level, things are far more complex than we imagined. The experiment's results reinforce the view that reality is not a fixed entity, but changes depending on how we perceive it. When photons in a complex quantum entangled state are measured, their behavior cannot be explained by local reality, as the classical view holds that everything is only influenced by nearby factors. Instead, they seem to be connected through an invisible network, transcend all limits of space and time in ways that traditional science cannot explain. This is like realizing that the world you live in is not a peaceful painting, but a vivid film reel. And you only manage to catch a few moments among countless frames happening simultaneously. This leaves us wondering, if reality is already this complex at the level of photons, how many other mysteries remain unseen? Could the three dimensions of space and